So this question is using some of our coordinate geometry skills. So two schools are represented by points A and B, and a road on line is through line R, essentially, that is the road. And we need to find the place for the bus stop on the road that is the equal distance from both A and B. So we know that if it's the equal distance from A and B, then we can find the perpendicular bisector, and where they cross, that will be the bus stop, because that tells me that it's the same distance from both of these schools. Okay? And that's actually what they're leading you through in the question. So the first part is to find the perpendicular bisector of AB, and then the second part is to find that point of intersection. So to find the perpendicular bisector, we know that it needs to cross through the midpoint and have a 90-degree gradient compared to, or perpendicular gradient compared to the original line of A and B. So if this is my original A and B, then my new line, which I'm going to draw in green, this is the perpendicular bisector, is going to be at 90 degrees, and it goes through this midpoint. Okay, so let's label the points on here. So we have point A, which is 220, and we have point B, which is 1424. So we're going to need both of those points. So the first thing we're going to do is find the midpoint between them. So the midpoint is kind of like saying the average of the x coordinates and the average of the y coordinates. So for the midpoint here, I'm going to do this in orange. I'm going to find the average, or adding them together. So 2 plus 14 divided by 2, and then the y coordinates there are 20 plus 24 divided by 2. So that's going to give me my midpoint. So that first one is 16 divided by 2, which is going to be 8. And the second one there is going to be 44 divided by 2, and that gives me 22. So my midpoint is 822. Then I need to know what was the original gradient. So what was the gradient? The change in y over the change in x. So of the original line, A to B, the gradient is the change in y. So I'm going to take this as 0.2 and this as 0.1. Okay, and then I can do y2 minus y1 over x2 minus x1. Or you might prefer to just think of this in terms of Pythagoras. Okay, or a right-angled triangle, and the rise, if you like, the change in y goes from 20 up to 24. So from 20 up to 24, which is therefore an increase of 4. And on the x value, I go from 2 all the way across to 14. So that is an increase of 12. Okay, so I have 4 over 12. Or you can use the formula, and either way you'll get the 4 over 12, which simplifies to 1/3. And therefore, so this is the gradient of AB, so the perpendicular gradient is therefore going to be -3. Okay, it's the negative reciprocal, or the flip and then swap the sign. So -3. So now I know that the gradient is -3 of the new line, and it goes through this point 822. So the equation is y equals mx plus c. We know that the gradient is -3, and I need to try and find what c is equal to. But I can substitute into here the x and the y coordinates that I know it goes through. So y is 22 and x is 8. So I know it works for that midpoint, and that will allow me to find the c value. And I can actually use my GDC for this. So I can do menu, algebra, and numerical solve, and I can substitute into here. So 22 is equal to -3 times 8 plus C, comma C, and therefore C is equal to 46. So use your calculator to help you. So we now know that the equation of this line is y is equal to minus 3x plus 46. Okay, so that's the equation. And then you need to make sure you write that in as the actual answer. So if you're given like an actual line to write that in on, make sure you remember to do that. So we have my formula. And then the second part is to find where the bus stop should actually be located. So that's the intersection. And if it was me, I think I would probably graph that on my GDC to find the intersection, because you're told in the question that the line R, or the road, actually has the equation minus x plus y equals 4. So you are told that information, it's just not labelled on your graph. So let's put that on here. So y minus x plus y is equal to 4. So I'm looking for that point where the two intersect from one another. Okay, so opening up a graphing page, I want to plot the line of y is equal to minus 3x plus 46. So that's my new line. Now you might be wondering where that is. It's just that we need to change our axis. So let's go up to 30. We don't really need this side at all. And this one goes up to 24 on my question here. So that's the new perpendicular bisector that I've found. Oops, not sure why that's doing that. And then I need to plot the existing line, the road. Now you're told the equation is minus x plus y equals 4. But we need it in the form y equals mx plus c, or y equals, to be able to plot it in the GDC. So if I rearrange that and add on x to both sides, then that gives me y is equal to x plus 4, or 4 plus x, either is fine. So if I press tab, then I can do that equation. Okay, and then menu, analyze, intersection. So click once to the left, once to the right, and then I can find my point of intersection, which is 10.5, 14.5. So that's therefore the place where the bus stop should be located. So the marks on this question, this is a lot of marks. You're given, first of all, 5 marks for finding the perpendicular bisector. So one of those is for correctly locating the midpoint. There's another one for finding the original gradient, and then for finding the perpendicular gradient. There's a mark for finding the C value, and then there's a mark for the final answer. And then for the second one, for finding the coordinate, there is 1 mark for the x value and 1 mark for the y value.